Okay, example 42. It says the curve shown in the diagram has the equation y is equal to f of x. There is a minimum point at p 4 minus 4, a maximum point at q 1, 2, and the curve cuts the x-axis at r minus 2, 0, s 3, 0, t 6, 0. We're asked to sketch the graph of f of 3 of x, showing the coordinates corresponding to P, Q, R, S, and T. So we'll start up by saying that, or first of all, we have to understand that this is a horizontal stretch of a factor 1 over 3. Now, the theory says that you can get from the graph of f of x, you can get the graph of f of ax, such that any point x, y on f of x will map to the point 1 over a x y on f of ax. All right. So this, as I said before, is a horizontal stretch of factor 1 over a, so that the y coordinates remain the same and the x coordinate is divided by a. So let's say points like r, which is minus 2. All right, r, which is, let's say, minus 2, 0. All right, let's just put something here. So if you have f of x and f of 3x, so points like r, which is minus 2, 0, is going to become minus 2 over 3, 0. Points like q, which is 1, 2, is going to become 1 over 3, 2. And points like s, which is 3, 0, is going to become 1, 0. All right, so in other words, I'm going to divide the x coordinate by 3 and the y coordinates remain the same. The point P, which is 4 minus 4, becomes 4 over 3 minus 4. And finally, T, which is 6, 0, becomes 2, 0. All right, so let's go down to the graph below this and do the sketch. All right, so below here I have a similar thing like what I have from the previous diagram. So now we can plot the points. The point minus 4 minus 6 is going to become minus 4 over 3. Minus 4 over 3 is the same as saying minus 1 and 1/3 minus 6. So minus 1 and 1/3 minus 6, which will probably get me about here. The point minus 2, 0 becomes minus 2/3 minus 2/3, 0. So that will probably put me about here. The point 1, 2 is going to come 1/3, 2. So 1/3, 2 would put me about here. the point 3, 0 is going to become the point 1, 0. That will put me here. And the point 4 minus 4 is going to become the point 4 over 3, 4, which is 1 and 1/3, 4, minus 4, supposed to be 1 and 1/3 minus 4. So that will put me about here. And the point 6, 0 is going to become the point 2, 0. That will put me about here. So at this point, I have enough information now to draw my sketch. All right. Well, it isn't perfect. All right. Let's try and get it as best as we can. All right. All right. So this is my graph of if the top one is the graph of if up here, if this is the graph of y is equal to f of x, this would be the graph of y is equal to f of 3x. All right. So we can so again we can get the graph of y is equal to f of 3x from the graph of y is equal to f of x by a horizontal stretch of a factor 1 over 3, and that in effect means that you're going to divide the x coordinates by 3 while the y coordinates remains the same. All right, let's see what we can go on to next. All right, let's talk about vertical stretch. Now the graph of y is equal to a of g of x, where a is greater than 1, can be obtained from the graph of y is equal to g of x by stretching the graph of y is equal to g of x parallel to the y-axis by factor a. What this means is that a point xy on y is equal to g of x maps onto the point x, a of a times y, on the graph of y is equal to a g of x. So in other words, the graph of y, you can get the graph of y is equal to a g of x from the graph of y is equal to g of x by taking all the points on y is equal to g of x. You would keep the x coordinate and multiply the y coordinate by a. All right, let's have a look at an example. All right, example 43 says, sketch the graph of f of x is equal to x squared, and sketch the graph of 2 of f of x. So we have f of x, and f of x is x squared, and we have 2 f of x, which would be 2x squared. There are some standard points on the graph of y is equal to, of f of x is equal to x squared. You have points like minus, let's say minus 2, 4, and that is going to become minus 2, 8, minus 1, 1 is going to become minus 1, 2, 0, 0 remains 0, 0. So in other words, remember, x, y on f of x is going to map onto what? X, 2y on 2 f of x. So the y, you're going to multiply the y coordinate by 2. So 1, 1 is going to become 1, 2, and 2, 4 is going to become 2, 8. So minus 2, 4, which is here, is going to become minus 2, 8, which is here. 1, 1, which is here, is going to become 1, 2, which is here. 0, 0 remains the same. You come here. 2, 4 becomes 2, 8. You come here. All right. And so the only thing remains now is for us to sketch our graph. All right. All right. So if this is the graph of y is equal to f of x, which is x squared, this is the graph of y is equal to 2 times f of x, which is 2 times x squared. All right. Let's see if we have time for another question. Example 44 says, the curve shown in the diagram has the equation y is equal to f of x. There is a maximum point at p minus 2, 0, a minimum point at q, 1, minus 2, and the curve cuts the x-axis at 3, 0, the y-axis at 0, minus 3. We're asked to sketch the graph of 3 times f of x. So we have f of x, and we have 3 times f of x. So points like minus 2, 0 remains minus 2, 0. 1 minus 4 becomes 1 minus 12. So we're going to multiply the y coordinate by 3. Points like 3, 0 remains 3, 0. And points like 0 minus 3 becomes 0 minus 9. We multiply the y coordinate by 3. So let's see if we can plot these points. So this point here is going to remain the same. Minus 4, 4 is going to come minus 4, minus 12. So this point is going to move here. That point remains the same. This point comes here. This point comes here. This point remains the same. And no other points. So let's see, try and do the best we can. All right, that's not going so well. So let's do it over. All right, so we have the graph of y is equal to f of x. And what we just drew, this would be the graph of y is equal to 3 times f of x. So to obtain the graph of y is equal to 3 f of x, from the graph of y is equal to f of x, what we do is that for every point on y is equal to f of x, we keep the x coordinate and multiply the y coordinate by 3, plot the points, and after we plot the points, we just then draw our graph. All right, and that is a vertical stretch.